So lastly, in our trio here, we have inverse tangent functions. Now, this standard integral formula is on your table, so we don't need to worry too much because we know that this is given to us. But what's important is that you do recognise that there is this 1 on A here, because a lot of students for some reason do tend to just miss that. And the other thing is very similar to what I explained in inverse cosine and inverse sine. This x squared here has to be 1x squared. Okay, it can't have any other coefficient. So the same rules essentially apply for all your sine, cosine and tangents. All right, so if that's given to you, we really just need to learn how to apply everything here. So we'll start off with question 30. Here we want to find the integration of 1 on x squared plus 4. So as soon as you see something like this, yeah, it should trigger your memory that I'm going to be working with inverse tangent. Okay, so I actually think that sometimes for students that's the hardest part in exams, is recognizing that this is related to this, yeah? And you can see that because it's given to you as a squared plus x squared, sometimes when you see x squared first, you don't quite think of this, but because it's plus, it could be either way. All right, so all we need to do after recognizing that we want to use this formula is to work out what a equals to. 4 is 2 squared, so in this case a just equals to 2, yeah? And now I substitute into this formula here, and remember there's that 1 on a, so this becomes 1 on 2, inverse tangent x on 2, and as always with our integration plus c at the end. Okay, so what you need to be careful with inverse tangent is that there is that 1 on a in front. All right, great, so that was question 30. Let's have a look at question 31 now. So here I want to find the integration of 1 on 12 plus 4x squared. Now, what's the first thing that jumps out to you when you see this? Exactly, you can see that there's a 4 in front of the x squared, so that should note to you I need to take that 4 out essentially. So I factorize the 4 out so that x squared is by itself, and I can just put a quarter in front of the integration. The 3 I've just made into square root 3 squared, and that's just to help me find a, which I can say, yep, that's going to be square root 3. And this, now I can use a formula, so that becomes 1 on square root 3, inverse tangent x on square root 3. And don't forget your quarter that you put out the front. A lot of times, because there's so much work in here, you forget about the fraction you put out the front, so just be careful with that. And we can just put that all together and always remember plus c at the end, yeah? So it is quite simple. I think by now, because we've done quite a few of these questions, it really is just getting familiar to the different formulas. All right, have a look at question 32 now. So here I want you to find the integration of this. Now, because there's a 2 in front, I know I have to factorize that out. With all our questions before, it's been quite nice to factorize out that number because this has been divisible by that. But this is going to give us a fraction, and that may frighten some students because for some reason we always get a little bit worried when the answers look quite funny. But don't worry about that, okay? Just remember, always factorize that out too, and if we have to make a fraction like this, that's okay. So take the half out, and now I need to find a. So a in this case is essentially going to be the square root of this, isn't it? So that means square root of 9 is 3, square root of 2 is square root 2. So it's going to be that squared. So a equals to 3 on square root 2. All right? So applying this formula, have 1 on a, and then have inverse tangent of x on a here, yeah? And don't forget you're multiplied by your half at the front. Now, we can't leave it looking like this. We do need to simplify it here. Your square root 2 is just going to get multiplied up there. And so that'll be square root 2, 2 times 3 is 6, yeah? Whereas over here, that square root 2 gets multiplied up there. So you get square root 2x on 3 and then plus c. And that's completely fine as your final answer there. So with this one, it's just important to note that even if your number here is not easily divisible by the coefficient in front of the x squared, don't worry. It's okay that we do get some square roots and fractions and etc. in our question. All right, so moving on to question 33 here. This is quite an interesting question actually, because have a look here. I want you to find the integration of x on 1 plus x to the power of 4. So this is quite difficult, because if you just look at that, it may not jump out straight away that we can actually apply this formula, because there's a lot of things that's different here. Not only is that x to the power of 4, so not x squared, but we have an x on top instead of 1. Yeah, can you see that? So here we have to use a special way of making it into this formula, and we use a method of substitution. And with substitution, what you do is you just let u or any other letter equal to x squared, all right? And that's because I want to make that into u squared, so I can use this formula here. Yeah, that's what I'm trying to do. So if I let u equal to x squared, then this will be, you can imagine, x on 1 plus u squared. Yeah, so that's what I want to use. All right, if I have this and I differentiate it, that's going to be du on dx, isn't it? Because that's u instead of y, and that equals to 2x, which also means, because I need a du here, if I'm going to differentiate in terms of u, that dx equals to du on 2x. So we start off with the integration of this, and let's make our substitutions now. So the x to the power of 4, I've made that into u squared, because remember, I let u equal to x squared. Now this is a difficult part. I can't leave it as dx there because I want to differentiate in terms of u. So what I need to do is change that dx into du on 2x, which we worked out here. Yeah, a lot of students get confused with that. All you need to do is, with your initial equation that you make with let u equal to x squared, just differentiate that and rearrange so dx equals to that. All right, now I've substituted that in. Can you see anything that we can cancel? Yeah, that's really good, because you can see that essentially this is just this multiplied by that, which means I can actually cancel the x and the x. Yeah, and that 2 is just half, which means I can actually just move that out the front. And now you can see we've gotten this, which is the formula. Yeah, so I can make that into, since a just equals to 1 in this case, we just have 1 on 1, so we don't need to write that, and inverse tan of u plus c. Now, because it's in terms of x, I always have to change it back. Yeah, there's so many students who, you've done so much work, you think, oh, I'm just going to stop here, but always remember, change it back to the x form. U equals to x squared, so just put x squared in there, and that's all you need to do for that. Yeah? All right, so that was quite a hard question, and I think it's good that we've worked through this, so if you do see this in the exam, you will know actually what to do, because otherwise you can see, if you had never seen this before and you just saw that, it would be really difficult to just think that, oh, I'm going to have to use an inverse tangent formula in this case. All right, great. Let's have a look here when we're going to be working with a definite integral. So I want us to work out, evaluate integration from square root 2 to negative square root 2. And over here you can see I have x squared plus 2. So it's this flipped around, but that doesn't matter. So first thing, I want to work out what a equals to, and that equals to square root 2. Now I can integrate that. So that becomes 1 on a, so 1 on square root 2, inverse tangent of x on square root 2. Yeah, and now just substitute in these. So I have square root 2 on square root 2 here, and here I have negative square root 2 on square root 2. So that's just going to cancel, and that's going to leave me with inverse tangent of negative 1. And remember, with inverse tangent of a negative, you can essentially just take the negative out. So just equals to inverse tangent of 1, okay? Yeah, and because we have a negative here and a negative in front of that whole thing, I can just make it a positive. So that's how we get from this step to this step over here. All right, so remember, inverse tan of 1 equals 2, 45 degrees, which is pi on 4. So that just becomes essentially that whole thing times 2, right? So with that, the 2 and the 4 will cancel, and that just leaves me with 2 on the bottom. So I get pi on 2 square root 2. Now I'm going to rationalize this, but it is okay to leave your answer as just that and not rationalize it, yeah? All right, so multiplying by square root 2 on square root 2, that gives me square root 2 pi. That gives me 2 times 2, which is 4, and this is my rationalized answer here. All right, so I think just the important thing here that people may have difficulty with was changing the inverse tan of a negative and just bringing out that negative. Otherwise, this question was quite straightforward.